So far we have seen only Linux basics which are required for DevOps, but I might start this session before starting our Linux session. But anyway, I thought to go with a sequence format. So first I would like to cover basics. Then I thought to jump onto DevOps. So in today's session, we are going to see what is DevOps, how it is useful, and what we are going to discuss in our further lectures. So it will give you a brief overview. How does it work and what you should learn out of this once the course is completed. That is the intention. Okay. So I'm going to tell you how does it work and what and all things you need to consider if you want to switch on to DevOps. It is little bit of different way I'm trying to approach. We'll see how does it go. So first of all, welcome back to my session, and I'm so much excited to start my DevOps classes. Okay, I'm eagerly waiting. Linux is a little bit boring for me because covering 30 days classes in 3 days, that is quite difficult. So here I have plenty of time or enough time to cover my stuff. So I may go in detail on each service or each tool to explain you whatever I know or whatever I'm working in my day-to-day life on DevOps. So that will help you to understand and cope up your skill towards to the DevOps. So with that, let's start. So in today's session, we are going to see why DevOps, what is DevOps, benefit of DevOps, and what is CI/CD, how does CI/CD work, and where do I CI/CD? Nothing but how to do the CI/CD and where you can do the CI/CD. So these concepts we are going to learn. Maybe it could be little differ than what I feel because me and Kumar sat and we try to understand how completely DevOps does work, and we put these slides together. And I would like to say thanks to Kumar as well. Okay. So with that, first we see why DevOps. Before talking about what is the DevOps, let's understand what the problem currently the industry is facing. Okay, I don't say currently it is facing, but they found a solution. But how they are achieving it. So the problem here is Dev versus Ops. Okay, you can understand what is the meaning of Dev versus Ops in a while. So first of all, let's discuss about the IT industry. How does it work? Assume that I have enough money and I got some idea. I would like to build that idea as a business. And whenever I try to build it as a business, I may need or I may require IT services if it is related to deal with the something on online. Let's take an example that okay, Ola or Uber kind of thing. Assume that there is no cab booking option, so people are going and taking the cabs by calling the people or by going out and searching for autos, and they are doing. So I got an idea and I would like to build an application which will help customers, my customers, they can able to book the cabs from mobile. So that is where the IT project gets generated. This is how the project requirement comes. So clients are expecting that okay, they have to get their business or go their business online as soon as possible. Nothing but I got an idea before somebody go and occupy the same business. I would like to make sure that I'm the first person, or else if somebody is already in the market, I want to beat them. So this kind of mindset I have. So I would like to build my application as quick as possible so that I can grab opportunity, and also providing services can be much quicker. That is my requirement. Next process, once the project is built and once it is go live, next is the providing services. I mean to say, first I have given a option to book a cab. Next I want to introduce one more feature, that you can book a cab with sharing. Initially sharing was not there, then sharing methodology came into the picture. So I got an idea that okay, I would like to build an application which helps to my customers that they can travel with other people as well. Then I can go with the sharing option. Now I have given this idea to my backend IT team, and I would like to get that feature as soon as possible. So that could be my requirement. If I say something, okay, I have this feature, then my IT team says that okay, it will be get delivered after 1 year or after 2 years. So it is quite annoying, and I may get disappointed, right? That is the how the business problems were there earlier. These kind of problems are there. So with that context, let's just come back. And business requires new features and changes. That is the expectation. So I may asking for the sharing, and later point of time I may introduce some other feature. So whatever features I'm expecting, that should be get delivered. Business needs new features deployed in days and weeks, not in months. So that is everybody looks like, right? So if something we want to get it, we will try to get it as soon as possible. Okay, that is where even online deliveries also, if you book some product, okay, earlier we used to wait around 4 to 5 days or a week to get it delivered. But nowadays, even they are charging some of the premiums. We are ready to pay that one, and we want to get it as soon as possible. Not only that one, our mindset is built like that with the opportunities whatever we are having. Similar way, businesses also, they want to get new features as soon as possible. Otherwise, it is quite difficult to handle their customers or their users. So that is the business expectation. I want to get new features as soon as possible. Maybe it could be a days or weeks, not like months. Now, dev job is to add new features. The developers are going to create these new features. Whenever I say in my travel app, I want to introduce new feature called sharing, that can be given to the developers. Developers has to build the new features. Next, ops job is to keep the site stable and fast. Next, operations team comes into the picture, who are handling these applications, where once the code is developed, that could be kept in the servers, which are handled by the operations team. Now, operations team mostly make sure that servers are always up and running with those applications. If I do some changes, my server may or may not work. Okay, that is the problem we were facing. So we were very reluctant to introduce new changes to our applications which are running on our servers. Starting off my career, whenever they are deploying some changes, we were very cautious. We all should be available, and if something goes wrong, it was quite difficult to recover our systems. So our intention is, I want to maintain my system is stable and up and running all the time, and could able to serve my customers whoever are using. Okay, that is the operations team intention. But code or features changes are integrated in the end of the development. Usually in the traditional deployment, what will happen, developers will be developing the code. Once all the developers has been developed their code, they can put together and try to integrate it. I mean to say, different people might be developed the same code, portion of code I can say, not the same code, and they put all together and they test the feature whether it is working or not. Then we may face the integration problems that okay, we are trying to one guy is trying to build in one way of thinking, another guy could be thinking in another way of developing. Whenever they try to integrate all together, it may not work as expected, or sometimes integration itself may not happen. So that is the problem. I mean to say, we cannot do the integration quite frequently. It may take longer, uh, more days, or at the end of the development cycle we were trying to integrate it. Next, integration was a long and unpredictable process. Nothing but whenever we are integrating, okay, it will take longer time, and also it is unpredictable process. Nothing but we don't know what is going to happen once the integration is enabled, or we are trying to integrate it. So the frequently degraded when merging. So whenever we are trying to integrate, okay, uh, that creates a lot of problems, and it is hard to manage, merge manually. So we need to put all the code together, and right, in the development process they may be using different functions or different ways of handling, and they are trying to give what I can say, APIs or different ways of developing, but all the code has to work together. Otherwise what will happen, uh, it cannot be able to integrate, and they have to start writing their code depends upon the code which is already working. So whenever you are trying to integrate after a quite long time, it creates problems. So, and lots of bugs are found at the end of the test phase. So once the code is somehow you have integrated and you are trying to test it out, you might found the lot of bugs. Let's take an example that, okay, bug is something like that. Okay, you have given a field called mobile number. Whenever you are typing the alphabetic character, still it is accepting. But in the mobile number field, it should accept only phone numbers. Similar way, in the email, it should have the other date. Even though you don't give at, still it is accepting. So these are the some of the examples of bugs. Okay, so whenever you integrate and you are testing this kind of bugs, maybe not this. So this kind of bugs can be appeared at the end of the testing phase. And again you need to go back. Okay, the if you ask the developer who has done that code, why you have developed in such a way, he will tells his assumptions. Okay, I thought so and so is comes over here, instead of mobile number it comes something else. Okay, so this kind of things you may hear from the developers. So test phase, you can find lot of bugs if the integration frequency is long. So obviously, as the code size increases, whenever you are developing more code, more and more code, code size increases, load of the test gets bigger. So you need to do lot of testings, and lot of bugs can be identified. So how long does it take to go from code committed to a code successfully running into in production? So usually, what do you think? Okay, how long does it take to go from code committed onto the code repository, I mean to say, and successfully running onto a production? Okay, usually it depends upon the environments, and maybe you can think that how much time usually does it take in your cases. So, but change is the root cause of most outages. So usually, whenever there is a change, most of the outages it happens means the behind the outage could be a change. Okay, even I do remember that whenever a few changes created a sleepless nights as a ops engineer for me. Okay, so I do remember. So changes, we were reluctant to do changes. Okay, and it should go a lot of process, change management process. If it is gone very well, and it is monitored very well, then absolutely no problem. Otherwise it may create a lot of problems. Now dev, usually they say, okay, it's not my code, it is your systems, nothing. But he says that, okay, I have developed my code perfectly and I have no issue, but once it is deployed onto your systems, we could see the problem. And they usually say that, okay, it works on my system. They usually say this dialogue. Okay, they say that, okay, I have tested it on my system, it is working here. If it is not working there, means there is a problem from your side. That is how usually developers says. Okay, and operations team, now it comes to the operations. Okay, mission is not working, that is the reason code is not working. Sorry, code is not deployed properly, or it created a problem. Then ops team usually says that it's not my missions, it is code, nothing. But before deploying that code, my mission was working fine. Whenever the code is deployed, from that onwards, my mission is not working. Okay, so that is how operations teams thinks, because till now it is fine. Some new guy came into my space, after that some problem occurred, then I think that, okay, due to the new guy, the problem has been arised. Okay, so the sorry. So now what we need to do, we cannot discourage changes in the interest of stability, or allow the changes to happen as often as it needs to. So we should not do that. Okay, changes are creating outages so that I don't introduce my new feature which helps to my business. At the same time, what I can say, allow change to happen as often as it needs. Or should I need to allow? Okay, let it create an outage, or should I can I allow the new changes even though it creates an outage? Okay, don't we have any solution? So you might heard about all this stuff. Okay, developers may say that okay, I spent 70% of my time is waiting. Why? Because developers are just developing their code, and once the other people also developed their code, all together get integrate their code, and then they do testing. So you can see most of the waiting time from the developer side. Next thing is infrastructure owners says that okay, I don't have space capacity. Okay, this was the earlier problem where cloud were not there, but hopefully whoever use the cloud, we don't see this dialogue. Okay, they say that okay, we don't have enough infrastructure to handle the all the systems or all the environments, nothing but a test, development, production, quality, all these environments. So they usually complain this one. Next to testers will say that our test systems are not realistic. So what does it mean by realistic? Your production might be running with the version 10, your test system could be running at the version 6 or version 7, or it may be a little advanced. So then how do you test? Okay, something you have tested at version 7 and same thing you are deploying at the production system which is running at version 10. Let's take a simple example that okay, your test systems are running with the RHEL 6 and your production systems are running with the RHEL 7. So if something you tested here, there is no guarantee that it is going to work on the production system because both versions are differ, even though it is Red Hat, and some features may not be enabled at the test systems and are available at the production system. Maybe vice versa, your test systems might be running at version 7, our production systems are running at version 6. Okay, so in those cases also your code will work on test systems with the latest features where you deploy with the same assumption, but you cannot see the it is going in right direction. And the next thing is L1 ops, nothing but who is handling initial cases once the deployments are done. So they usually get the calls and they don't know whether they have to approach the uh, dev team or ops team where the problem has been occurred. And app support, okay, nothing but who are handling this one. They are uh, going to get lot of calls. Okay, even they are getting that from the customers that okay, what's happening and what's the problem. Okay, next, the who is the business owner? Okay, LOB executive. Uh, he thinks that okay, I have given my new requirement to my IT team, I don't know what they are doing, still this is not work coming. Moreover, my existing applications are not working now. Okay, let's leave the new feature. My existing application went down, so I'm my customers, I could not able to serve to the customers. So these kind of problems we might have we might have seen with the sorry, with the process what we were following. So is there any better way to handle all this situation? Okay, so we are facing the problems while developing the code, we are facing the problem while deploying it on code, we are facing the problem infrastructure and also the testing environments, all this stuff we are facing the problem. Okay, so is there any better way to do? And have you seen that okay, some of the big players like Facebook, Google, Amazon, okay, all these guys, have you seen that their applications went down, or uh, have you seen that they are releasing new features quite frequently? So that is how it works. So Amazon is deploying one deployment. Amazon, they are deploying more than one deployment every second. Okay, per day around 8 86,400 deployments they are doing. So these are the sources where you can check it out. So these many deployments they are doing, even though lakhs of customers are crores of customers are using their applications. Next, Netflix is deploying 1,000+ deployments every day, and Etsy is deploying 50 deployments every day. Flickr is deploying 10+ deployments. Facebook do one deployment every day. Okay, this is moreover 2012 data, maybe latest data. They might be doing more deployments. How do they do? Okay, because we are struggling to do what I can say new features in years or months, to be honest. But these guys are doing so many deployments every day. How does it possible? Is there any better way to do that one? Okay, so the better way is dev versus apps to dev and apps. So instead of you are thinking that okay, development and operations are differ, if you combine these two, then you can able to achieve whatever I said. How the big guys are doing, same thing you can do. So the dev and apps nothing but working together. Development and operations team working together. That is where the DevOps comes into the picture. So what is the advantages of working together, dev and apps? The first advantage is it is quite what I can say easy to do your deployments. I mean to say, you know what's happening at the as a developer, I know what is there in the operations side, and as a ops guy, I know what they are developing and what do they need from the development side. So whenever you have this clarity, instead of thinking that okay, I don't know what developers are doing, whatever they are deploying on my server, I will just take care of server. Similar way, developer, if he is thinking that I don't know what kind of operating systems or what kind of applications they have installed on their target system, but this is my application, so if I give this one to him, or if I throw it on his face, let him get it deployed or make it work. Instead of thinking like that, if you both guys can work together to achieve the problem, okay, what is the target infrastructure you have? If you are having so and so version, according to that I am going to build my application. Similar way, even operations team can ask the developers that okay, what application you are developing, what could be the prerequisites, how do you want to deploy? If you have this proper communication, you can able to send what I can say, deploy your code from the development phase to production level with a proper flow. So the smooth collaboration will happen if dev and apps is working together. That is first advantage. Next, feedback. Once it is deployed, whatever problems you are facing, those as a operations engineer, we can discuss with the developers. We can say that okay, after deploying your application, so and so bugs we have identified or problems we have figured out, then he can able to develop and he can give, and while giving his code again, he says that okay, these are the dependencies. So that is how the feedback process does work. Both can work together and they can give the feedback. And continual experimentation. So if you do same process, I mean to say this process repeatedly does work, then we can call it as a DevOps. Okay, so operations team and developers works together and they can able to do or enable these features or these working culture, I can say. Okay, then we can call it as a we are using DevOps. Why DevOps? We just talked nothing but what is the industry problem they are facing. Now we are going to talk about what is DevOps. Before moving to here, does anybody have any questions? Let's move on. Now we'll discuss about what is DevOps. So far, why we need DevOps? We have understood the problem, and we know that okay, some new feature we should need, that we are saying that it is DevOps. So now let's understand what is DevOps. Let's first see what is DevOps is not. Okay, if we know that okay, what is not DevOps, then you can easily understand what is DevOps. So DevOps is not automation. Okay, I mean to say it's not just an automation. If you think that okay, something is automated, then it is DevOps. No, it is not just automation, and it is not just build and release as well. Let me take a pen. So it's not an automation, and it is not a just build and release, and it's not just an infrastructure development, nothing but building infrastructure, and also it is not just a system administration. Okay, so then what is DevOps? So the DevOps, what does DevOps actually? Okay, yep. So now what is DevOps? So the DevOps is okay, communication, nothing but we are going to communicate together as a developers and operations, and integration nothing but working together with the lot of applications. Then collaboration, nothing but we can collaborate together and work. So this we can call it as a DevOps. So you should able to communicate and integrate and collaborate. So we are going to see what does it mean in the little later. So ops who thinks like a devs, that is what I was thinking. So operations guy can able to think like a developers, and devs who thinks like apps, developers also who thinks like apps. If you do that one, then we call it as a DevOps. Now DevOps is a culture. It is not something like a technology, or it is not something like some what I can say automation. It is a culture. You can able to collaborate, communicate, and integrate. If it is happens, then we can say that okay, we are having or we are following DevOps culture. So culture of lowering risk of change through tools. So now how we can do that one? I'm saying that collaboration, right? So the collaboration will happen, okay, by using some tools. So the culture of lowering risk. So what risk do you lower? That is of a change through the tools. We are going to change in our application with the tools. So we use some tools which will helps to follow our DevOps culture. Rather than we are going to communicate directly or doing something, we in between we are going to use some tools. Those tools make our work easy. So the DevOps culture expects respect each other, either operations team or a development team, and trust each other, and healthy attitude of failures. Nothing but even though failure happens, you should take it as in the positive manner, and you need to find out root cause and avoid blame. You should not say that okay, because of this it happens and because of that it happens. If you could able to build this culture with your working environment, then we call it as a DevOps. Okay, so I just talked about all this stuff. Now DevOps is incomplete and interpreted wrong. Okay, if what I can say, it is incomplete and it is interpreted wrong if you don't follow these practices. Okay, now we are going to talk about the continuous integration. So DevOps practices are involved all this. So continuous integration we are going to do, continuous delivery, this is we call it as a CI, this is we call it as a CD. Then microservices, next infrastructure as a code, monitoring and logging, and communication and collaboration. So these practices comes into the picture. So now if you see here, we are trying to convert a culture into a IT tools. Okay, so we were talking about the communication, integration, and collaboration. Now we are trying to bring those into the tools. Okay, that is the intention. So these are the continuous integration we need to do in the DevOps practices, and continuous delivery. We are also going to use microservices and infrastructure as this code, monitoring and logging, communication and collaboration. Okay, so before going to the DevOps, okay, there were other way of methodologies, way of working methodologies were there. So among them, agile methodology. So whenever we talk about the end-to-end life cycle of a software development life cycle, so first we need to plan, then code, then build, test, release, deploy, operate. Okay, so yeah, operate. So these are the steps we should follow in the software development life cycle. So first, initially we were doing like agile methodology. Agile methodology can able to cover up to plan, code, and build. Whenever it comes to the continuous integration, so continuous integration is going to cover until test phase, and continuous delivery covers the releases as well, nothing but you can able to release. So there is a difference between continuous delivery and continuous deployment. We'll talk in a while. Now come to the continuous deployment. It is going to deploy on the target environments. Even in continuous delivery also it happens, but I will tell you the difference. Now if you follow the DevOps methodology, which collaborates continuous integration, continuous delivery, and continuous deployment, you could able to achieve the full software development of life cycle. So that is the advantage of using DevOps. So now we understood what is DevOps. Okay, DevOps is a culture, and we need to follow some certain parameters. If you could able to follow that one, you can achieve the DevOps culture. Now, benefits of DevOps. If I follow that one, or if I enable whatever we talked about, whatever culture we talked about, if we enable in our working environment, what are the benefits we are going to get? That we are going to talk now. So release velocity. So this is first benefit. Then deployment cycle, deployment rollback, defect detection, recovery from failure, collaboration. Collaboration and performance oriented. So these are the benefits we are going to get. Now we'll talk about the release velocity. Release velocity, nothing but we can release velocity helps to release code to production more often and with more confidence. So if we follow the DevOps methodology, so what will happen? Instead of waiting months or years together for deploying a feature, we can able to deploy it quite often on the production. Even a small feature we are introducing, we can able to deploy it on the production without any issues. So it improves the release velocity. Next, the complete development life cycle from initial design to production deployment becomes shorter. Okay, that is what we were talking, right? DevOps, nothing but it covers the complete development life cycle. So it will become very shorter, nothing but we can able to develop small feature. Maybe we can deploy uh, more than one deployment every day. Okay, if you build the efficient DevOps culture. So whenever code is developed and it is already built and you can deploy it in the production, which will happens in the minutes of time. Okay, so if we enable, the deployment lifecycle becomes shorter. Next, deployment rollback is easy in case of a bug in the code or issue in the production. So whenever we deploy the new feature, if the new feature is not working or something is not working as expected, then we can able to roll back quite quickly. This gives confidence in the releasing features without worrying about the downtime of rollback. Downtime for rollback. So if something goes wrong, we can able to roll back quite easily. Then we don't think about that. Okay, if I do the new deployment or new feature, if I introduce, my application doesn't work. Whenever the new feature is not working, I can able to roll back quickly. Within minutes of time, my old application will be up. Then as a customer, I will get confidence. Okay, if they ask for downtime for very lesser time, okay, I'm fine with that one. Maybe something where I have less users or less customers are using my application, at the time I can give that opportunity. Okay, so deployment rollbacks could be quite faster. Next, defect detection much easier than releasing to production. It improves the quality of the software. So whenever we comes into the DevOps methodology, your test environments, quality, what I can say, development, all the systems are at same level even with production, and we can able to find out the defects quite easily before going on to the production. Okay, that is the advantage of using That is one more advantage. Next, previous versions are well maintained. That helps to recover from failure very fast. Sometimes even your production systems may go down. Still, don't worry, because you have the previous versions of codes on the Artifactory artifacts we called, so Artifactory repository, so we can go and fetch the last deployed application and we can deploy it in the systems. So it could be quite faster of the recovery in case some disasters happens. Next, collaboration between development and operations professionals increases. So collaborations also going to increase, so your developers and operations team communicate quite frequently, and it also increases the professionalism as well, right? Next, organizations follows performance oriented culture in which teams become more productive and more innovative. So whenever you have a better way of working, you don't get distracted and you will focus on your performance rather than deviating from the actual work what you are doing. Okay, so this is another advantage. So those are the major benefits of using DevOps. So you are going to improve your way of working. Now, what is CI/CD? So far we have talked about DevOps. In the DevOps, we know that okay, CI/CD is the part of DevOps. If I do remember some time back, okay, somebody asked this question: what is CI/CD and DevOps? Now you can understand. So in DevOps, it is a combination of CI/CD. We'll see how does it work. Now, in the DevOps process, first we'll talk about the continuous integration, or CI. So CI stands for continuous integration. So what is CI? Continuous integration is a DevOps development practice. So the developers, whatever practice they are following, that we call it as a continuous integration, where team members integrate their work frequently. So we have 10 developers who are working on different modules of code, and we don't need to wait to integrate their code until what I can say project delivery comes into the picture. Every day we can integrate whatever code we have developed, and we integrate it and we test it out whether the integration is working or not. With that integration, something is working or not. Okay, that is how the integration will happen quite frequently with the continuous integration. The meaning of continuous integration itself is you should integrate your code continuously, and leading to multiple integration per day. So as I said, we can integrate multiple times in a day, so that it could be quite easy for you to understand on which direction your code development is going. If something is deviating from the actual work what is doing by your peers, you can correct it at the starting stage of your development cycle. Otherwise, you developed a feature which works with the some particular plugin, but your other developer is developed in other way of thinking. Whenever you try to integrate, you are expecting some input from the other developer program, which is not done by your other developer. Again, either one of you has to rewrite your code. Okay, so which delays your development life cycle process. Next, how does it work? So each integration is verified by an automation build. So we need to automatically build whenever the integration is happens. Okay, and including test. We also going to test once the build is happened, and to detect integration errors as quickly as possible. So we can easily detect the errors whenever we integrate and we build the code. If it is building is not happened, something went wrong, so we can fix it. If build is happened and you are not getting the expected output, again you can go and test it out. Then purpose of CI, it improves the quality and decreases the frustration. So the quality is going to get increased. You can do the better way of managing your new features. And also you don't get frustrated. Why? Because we don't tell that okay, all the bugs are come together, and if I ask you to work that, okay, so many bugs are there. Rather than if you do the small piece of code integration, it could be quite easy for you to fix the small bugs, and it avoided the larger bugs at the later point of time. So that is CA. And reduce communication gap. Okay, so we frequently doing this one. So we don't want to blame others, because we can identify the problems in the quicker, and we no need to discuss unnecessary stuff. So it reduces communication gap, and with early feedback we could able to find out okay, what went wrong while we are deploying or we are testing the new feature. Okay, so the integration will happen quite frequently. So assume that this is my actual application. I can take it as a branch and try to collaborate quite frequently. So whenever I integrate, if it is working fine, I will proceed further. Something like that, the integration does work. Anyway, this we are going to see more on our Git chapter. Next, CA is the practice but not a tool. Okay, continuous integration is not a tool, it is a practice. But to achieve that practice, we are going to use tools in the background. Okay, so requires discipline from the developers team. So CA mostly works with the developers. So developers has enough idea or fair knowledge of how CA does work. Now, process of CA. So development, source code management, nothing but source control. So they will commit the code onto the source code management and integrate CI process. They are going to build the code whatever they have pushed. I mean to say, building is the code will build, then testing, it will get tested and report. In case if it is successful or failure, or it find some bugs, the information will be shared with the developers. Again, they are going to do the same task. So this we call it as a continuous integration. So the components of continuous integration, we need repositories. Repositories nothing but the what I can say, the repositories where we can store our code. And CI server, nothing but test server. So then build server. Okay, build nothing but code build will happen, and we can test it. So what happens, CI server is continuously monitor repository if there is any new code is there. If developer commits any new code, it detects the code and it build the by the CI server. Okay, sorry, it built by the build server, and CI is the monitor, nothing but who is observing what's happening, and who manage the other part of I mean to say, other systems which are in the CI part. Let's in this case, if we take example of Jenkins server monitors the repository in our case, if we talk about Git. So Jenkins server as a CI server monitors the repository, and whenever it detects a new code, Jenkins server may have slaves, so it gives to the slave system, or it it may build itself. Okay, in those case, CA server and build server becomes both are same, uh, and it build the code and it give the build output. Build output may be a what I can say, artifact. Either it could be a new feature files, or else it give the reports that what went wrong. Okay, so this is how the CI process does work. So then the CI is going to report the developers, okay, what was the outcome of the process, sorry, new build, and whether it went successful or failure. So this is how CI does work. CI is composed of connection to repository. So repository we are going to connect, and build script we are going to build, and the feedback means such as mails, we may receive the reports or feedbacks to the developers, and the process of integrating source code modification. So we are going to integrate source code. It could be inclusive of test, inspection, deployment, and feedback, all this stuff. So these are the things will happen at the CI level. Next, build in CI means a series of process. Okay, we are talking about build, right? So it is a series of process which will happen or occurs regularly, and rather than the so-called compilation that is executed at the time of committing. So instead of running at the, what I can say, mm, single time, or at the end of the development phase, running at a single time is not a build. So build is in DevOps, it will be a continuous process. Now, next, it could be you just need to think how long would it take in your organization to deploy a change that involves just a single line of code. Okay, so you just think if you are already working. In my case, it may be take hardly 1 hour, because even I was deploying some new code yesterday in my development environment, which was what I can say, hardly took 30 minutes to 1 hour with the approval process. Okay, so it depends upon if you are using a DevOps methodology, it is quite faster. Next one is we are talking about continuous delivery. So far we have talked about continuous integration. So in the continuous delivery, what is continuous delivery? It is a small frequent changes continuously integrated into the production. So far we have build and test it. Once test is done, then the continuous delivery comes into the picture. Now whatever build outcome you are getting, that you need to deploy it in our production systems. Okay, so the production systems should get the a small piece of code. Whatever new features you introduced today, maybe by today, end of the today, I am going to deploy in my production system. That's how it works. So design, develop, test and release. Okay, so this is the process we are going to follow in the continuous delivery. Now, continuous integration to continuous delivery, how does it go? So first it will happen the continuous integration, then continuous delivery. So CD is the next step of CI. So we have already discussed about CI. So CD is the next step of CD is the next step of CI. Every change to the system can be released to production. So whatever changes you are doing, we are going to release that into the production. Next, delivery can be done at any time on any environment. This is the one of the best advantage of using DevOps. You can do the deployment at any point of time at any environment. Any environment means it could be a development environment, test environment, quality acceptance environment, then production environment, or pre-prod and production. So in these environments, you can do at any point of time. But there is a certain process you should follow. Maybe we are going to discuss in going forward classes. So now, just to make sure, remember that continuous delivery and continuous deployment both are not same. So you can see the difference. So continuous delivery, what will happen? First code is done with the CI, and unit test and platform test is done with the what I can say, integration. Once that is done, then it is going to integrate acceptance test. Here manual acceptance comes into the picture of the continuous delivery. If you want to deploy into the production, then you need to approve it manually, then it will go and deploy into the production. Post deploy test, once it is deployed on production also, we may do the testing. Okay, so this is the continuous delivery. But whereas continuous deployment, everything is automated, even acceptance also get happens in automated, because whoever is authorized person, he just need to accept it. Once he accept it, it automatically gets deployed into the production. So this is the continuous deployment, where we are going to see in the quite later sessions. Okay, next, why CED? It improves the what I can say, deployment of the new features into the uh, hours rather than weeks sorry, rather than days, weeks, or months, it reduces to the hours. And apart from the continuous delivery, there is a Kanban. Even in some of my projects, we are still using, which takes the days. And Mm. Iterate deployment, it takes weeks. Under waterfall methodology, it takes years. If you don't know all this stuff, these all are the old methodologies which we were using in our development lifecycle to deploy our applications. Okay, most of the companies are not using any of these right now until there is a specific requirement which continuous DevOps is not suitable for them, right? Then how does it work? So CD is going to work in having a collaboration working relationship with everyone involved. So we need to collaborate with all the people who are working in this particular environment. So use deployment pipelines which are automated implementation of your applications build lifecycle process. I mean to say here CD continuous deployment. We need to create deployment pipelines. Okay, so the entire pipelines, if we create it appropriately, which achieves the total life cycle, application build life cycle. Next, this is regular, repeat, sorry, rapid, repeatable, reliable, and reliable changes. Okay, so we have to do it regularly and rapid, quite faster, and it is repeatable and reliable. Next, DevOps tools. So these are the tools we are going to use uh, on the each segment. And in the version control system, we have a lot of tools. You can see here Git, Bitbucket, Perforce. And whenever it comes to the automated infrastructure, we have Jenkins. Okay, this is AWS service called Code Build, Ansible, and Docker. Then collaboration, we have the Skype and Slack channels, and this is AWS SNS, I think, yeah, SNS email services, and also shared matrix, nothing but monitoring. This is CloudWatch, Grafana, Prometheus, and few other services. So, like this, in each sector or in each area, we have different services are there. We may choose one of the service or one of the tool at the each segment. Apart from this, we need few other, but yes, instead of CloudWatch, we were covering CloudWatch, but we are going to see the Grafana and Prometheus over here. I will update my slides. So these are the some of the what I can say tools we are going to integrate more to make it work. Okay, so now we are going to see how the entire DevOps lifecycle goes. Okay, so you can see here, this is the entire DevOps process we have set up. So project and task management, nothing but who are going to take the requirements. You can see here requirements engineering. This segment is a requirements engineering. Once the requirements is taken, then it will go to the development and configuration. Nothing but developers are going to push their code into the source code repository. Once it is what I can say pushed into the source code repository, we are going to build it. Nothing but compile, nothing but we are going to build the code. Once build is happened, then unit test happens. Once unit test happens, static analysis, nothing but Sonar Cube. So static analysis will happen. It will tells you that how the performance of that application. Then we are going to package, nothing but if it is needed the multiple versions, then we need to pack it appropriately. Your code may not work with without some dependencies. You need to include all those dependencies and you are going to pack it. Once it is packed, then you are going to do the environment provisioning. So this is again environment provisioning, nothing but to deploy this application, we are going to provision the new systems. Once the new systems are provisioned, then we are going to do the system of records and service virtualization. So in this case, what will happen, some dependencies may required to make it work. Assume that if I want to, what I can say, if I want to do testing my application, it may expect other applications to give some input, or other applications should take the what I can say output of this application. So in those cases, some of the mock tests we do, so that we can do the system of records and service virtualization. Once it is done, acceptance test. If it is working fine, then we are going to do the acceptance test, which will tells you that whether it is working fine or not. Once the acceptance test is done, ready to release the software, so we are going to release that software. And once release is done, then performance testing. This application, how many resources does it require, or is it performing better or not comparatively previous one? And load testing, nothing but how much load it is generating, okay, to serve these many customers. Once it is done, deployable software, we create it as a deployable software. That deployable software goes into the production environment. Once production environment is done, then client or owner of the product is going to approve that, okay, this product is fine and we are going to use it. So this is the complete DevOps life cycle. But in these cases, some of the stages may be skipped by some of the projects. Again, it depends upon the project need, whether do we need to follow all this stuff or not. But this is how the entire life cycle, software development life cycle does work. Software life cycle does work. Okay, so let's see how does it go. Sorry. So first you can see here, it is going to the development and configuration. They are developing. The code is get pushed into the source code repository, and this code will go to the compilation. So the code is compilation is done, then unit test is happened. So it reports the what I can say unit test cases, and it gives the output. And then static code analysis, and then packaging. Once packaging is done, then environment provisioning, whatever servers are required, maybe Docker systems or something, it is going to provision. Then marking, nothing but to make it work, we need to test it completely. So some mark we do, then acceptance test. After acceptance test, report will go, then deployable software get generates, and we do the load testing. What is the load is happening, then performance testing. Okay, I went in the reverse way. Yep. So then ready to release, then it will go to the what I can say client, or what I can say product owner, then they approach to the for the deployment. Okay, so this is how it goes. So this is the complete software development life cycle. In these cases, wherever you want to use your tools, it's up to you. Okay, whether if I want to skip some steps, I can skip it, or if I want to use some tools rather to achieve this one, I can do. Now if comes to the tools, this is how it works. So management and tracking, we can use the Jira, and developers may use the IDEs, that is Eclipse, and what I can say Microsoft Visual Studio, or some other. Then source code management, it may be a Git, or Perforce, or GitHub, Bitbucket, anything. Then compilation, we are going to use the Maven. All this is runs on the Jenkins server. Then unit test, Selenium, JUnit, or Proctator. Then static code analysis, SonarQube. Packaging, it done at the Artifactory level. Then environment provisioning, we are going to use the Puppet or Ansible to provision our environments, even Docker. Then systems of records, where we are going to mark the some of the environments, that can be done with the CA Lisa. Then acceptance text, then here also Selenium, Proctator, and HP, they have their own tool. Then development software, once it is a packaging, right? Then load testing, there is a load runner is there. Then performance testing, again load runner and JMeter, and ready to release. Once the client and product owner is approved, then it will go and get deployed into the production environment. It may be a AWS Cloud Foundry, or Azure, Google Cloud, maybe your traditional data center. It could be anything. So this process can work anywhere. So you can see the how these tools are going to help us to do the entire this software development life cycle. Okay, so this is how what I can say, other tools are there. You can see here, addition to whatever we can use, we have added few other tools at the each level. Okay, you just have a look, and here we are going to use Ansible. I didn't keep it. Yep. So these are the some other tools, and don't think that okay, few people will comes and says that okay, I want to learn a lot of tools in the same level. So in the same environment or same location, why do you need to learn different tools? If you learn, okay, yeah, quite frequently this question asked by so many people. Okay, whenever I say that I'm teaching Ansible, don't you teach Puppet and Chef also? See here, all Ansible, Puppet, Chef, all going to do the environment provisioning, nothing but continuous deployment. You are concentrating more over here. What about these tools? If you don't know these tools, you don't know the complete DevOps flow, right? So you should take or pick up one tool at the each level, and you can build your own DevOps profile. That is how you need to do, rather than concentrating on this one. If I do learn more over here, and if I say DevOps, okay, it doesn't work. Okay, so like that there are various tools, but I have already discussed about what tools we are going to use in our case. So we are going to use the, what I can say, Git over here, Jenkins for the what I can say, CI tool. There we are going to talk about Maven. Anyway, JUnit we are going to use for unit testing. SonarQube here, Artifactory or Nexus, either would be fine. And here we are going to talk about Ansible. And this service virtualization we don't require. It is comes into the real application if you are doing, and it comes more into the testing team involvement, not the DevOps engineer involvement. Even acceptance test, load, what I can say, load and performance testing also doesn't comes under to the DevOps part, because it is a complete life cycle. Okay, so those tools, and we are going to use the this area. We are going to talk about the EC2 instances on AWS and Docker and Kubernetes. So this one and this one, this, these are the tools is helps us remaining all. If you see, this is something related to the management related stuff. This is comes into the testing. These all phases comes into the testing. Okay, acceptance test. Okay, because testing we don't deal. Service virtualization and acceptance test, performance test, load test, all these are not part of the what I can say, DevOps cases. These are done by the testing teams, which is a entire other way of working. Okay, so what is the ultimate goal of using DevOps? Okay, how does it help? It helps in the prospect of the performance. So high performers are more reliable. So you are going to get the success rate of 2 times. Nothing but if you deploy a change earlier, 100 changes if you are deploying earlier, if the success ratio is 40%, now it becomes to the 80%. So 2 times better or is going to more successful than the failures. Or else take in this way, if 100 changes you were deploying earlier, if 30 changes were failing, now once you what I can say, start using DevOps, it may come down to, it comes down to 15. And also it is faster than earlier. If you are deployment is taking around 12 days earlier, now it is takes only 1 day. Okay, 12 times faster than the earlier. Okay, MTTR time is mean time to recover. Okay, I mean to say, sorry, not deployment, recover. To recover your system, if it is taking 12 hours earlier, if you are using DevOps psych process, then it is going to recovered in 1 hour. And also uh, 2 times more likely to exceed the profitability, market share, and productivity goals. So the timelines has been drastically decreased if you by using the DevOps methodology. You can reduce your time. If you the development of the product is taking earlier 2 weeks, it comes down to the a week or lesser than to that. And 50% of the higher market capitalization growth over the 3 years. So the business owners also get satisfied more. Why? Because earlier if it is taking around 6 years to get improved their business double. Maybe it takes the 3 years this time. So that's how it is going to help. Now it's time for questions. So far whatever I have discussed, it is more related to the I can say more it is like a mindset. Okay, maybe I have talked about here and there tools, but whenever you are ready to learn DevOps, you need to set your mindset in such a way that I need to collaborate and discuss with the developers, and I could able to understand their problems, and I could able to manage the situation, and even as a operations team. So to achieve this one, we are going to use some tools. That's how it works. So with that, I'm stopping over here and open for questions.
Even without any prior experience, this is possible, right?
Yeah, it is possible, but as I said in my first demo lecture, I said that okay, if you are not from the IT background, you cannot able to work on this. Why? Because as I said, it is a process. Whoever already there, they know the problem. Now it is quite easy for them to imagine or convert these into the tools. So whenever I am talking about some tool, you background, you can understand that what exactly or how does it help you.
Right, that's anything, any tool we need to practice before coming here.
No, I'm going to teach you each and everything how to do from logging to a server as well. I don't have any problem because I want to take you the step by step. I don't want to get disconnected somewhere. So I will try to go from basics so you can understand each and everything. Ultimately, you feel that, okay, I'm doing something new. You any other?
Hi, this is Nidhi. Yeah, I have
Yes,
a question. Uh, can you go to the previous slide where you were showing all the different tools? Uh,
this one.
yeah, this one. Yeah, this one.
Yeah.
So you mentioned about environment provisioning. So
Mhm.
can you just explain a little bit more? And is this part of DevOps? Like this specific environment provisioning, that stage, is it part of, is it considered part of DevOps?
Yes, it is part of DevOps because environment provisioning nothing but you want to deploy your application. That is what we have talked. As a developer, he developed some Java application or .NET application. He has given to me that, boss, this is my application. Please deploy it on the system. Now to deploy that one, he also gives the what I can say dependencies. Nothing but what softwares does it require before deploying it. So if he has given that information, with that information we need to provision new systems with all these dependencies, either in the automated way and
Okay.
or else you can create or you can install it manual. Whenever you use configuration management tools like Ansible, Chef or Puppet, what does it do? It actually automates the most of the installations. For example, take a Java application. Before deploying a Java application, I want to install Tomcat. Now you can go and create a new system and install the Tomcat and then deploy this application. That is one way. Other way is you can tell to your tool that go and create a server and install Tomcat. Then copy this artifact or code into the target system. That you can tell to your tool. So in these cases, we need to provision required infrastructure to deploy our application. That is the major part of as a DevOps engineer rather than writing code. Code writing is not part of the DevOps engineer. Developers develop their code and they also collaborate with the DevOps engineers. We mostly manage the infrastructure. Okay, so moreover, it is our major part because we are going to talk about Docker over here, Ansible and Kubernetes. So three tools comes into this picture itself. Yes, this is what we need to do. We have to provision the new systems and configure it according to the developer requirements and manage it.
Shankar, Meghna here. Just want to know about Jenkins. You told no continuous integration, right? Just want to know about it. What exactly is that?
See, Jenkins is not continuous integration. Okay.
Okay.
To achieve the continuous integration, Jenkins is one of the tool. Apart from Jenkins, we have Circle CI is there, Travelser is there. Like that, we have different tools again are there. So what CI tool does do, it takes the code, build it, create artifacts and store those artifacts in some location. To do that activity, we need one guy. That guy is Jenkins. So Jenkins guy, what he is do, he will take the code from the developers where they have pushed, I mean to say repository. It takes the code from the repository, it builds it, it tells to someone that okay, build this code. If once he build, it takes that build and it do the unit test. Again, it tells to someone that okay, do this unit test. Once it is done, then it takes that code and put it in somewhere where you can go and take that one.
Okay. It's a kind of it's a tool, right? Just we need to
Yes.
write a code. We no need to write a code. Just
See,
what exactly?
it is a tool. Yes, Jenkins is a tool which helps us for CI. Now, writing code is up to us because whatever process I told, this you can do in the GUI, nothing but graphical user interface. Mostly we do it with the GUI, and also we can write a code that we call it as a pipeline code. So both way is there. Pipeline code is something we need to generate it, okay, with your requirements. Once it is generated, we can give that one rather than go manually and create a job, or else we can what I can say, write the pipeline scripts. I will explain both the ways.
Okay. Yes.
Yeah, hello, Shankar.
Yeah, go ahead, Elipan.
Actually, you were saying DevOps is a combination of a developer and operation team. So, is there any way testing team comes into the picture, because there are performance testing and unit testing?
Yeah, most of the cases in dev team itself, they do the testing. Okay, testers also comes into the DevOps team, but if it is what I can say, bigger project, the project, one of the project which I worked, we were having around 100 members of team, where 40 members are just developers. So they used to develop their code, and we have created a separate testing team. So once we have deployed this one on the target servers, testing team do the some testings, nothing but whether application is fine or not, performance is fine or not. Yes, so like that it will be. Otherwise, if it is small projects, testers also as part of the development team, and the unit tests are most of the cases done by the testers itself. They have to write the unit test cases, and they have to do this stuff. But in this case, okay, most of the cases it is what I can say, avoided. And this performance testing, all this stuff we are going to do at the initial process of application building. Nothing but first time you are building your application, so far it is not yet available. Let's take that. Okay, as I said, I want to, what I can say, implement a new application which resolves the customer problem, like cab booking. So first time whenever I do, all this stuff comes into the picture. In the subsequent deployments, it won't come into the picture. Why? Because you are going to do the very small piece of code which you cannot do these kind of tests every time. Okay, so initial phase testing team will comes once initially product is up and running on production. In the subsequent cases, mostly we don't what I can say, follow load testing, performance testing, and acceptance testing. All this stuff doesn't comes. Only unit tests we are going to do. Those unit tests are already going to happen at the Jenkins level. Once it is done, we can deploy it.
Meghna here.
Yes, Meghna.
Very nice explanation, Shankar. Because I've seen some videos and some other things where I was not understanding what exactly they were. But this presentation was very nice.
Thank you, Meghna.
Minhaj here.
Yeah, Minhaj, go ahead.
So could you explain me a little bit about service virtualization, like CA Lisa?
Okay, see, just consider that this all comes into the picture at the initial development phase, nothing but whenever you are developing new application. Let's take an example that, for example, you are creating a car first time. Okay, so new model of car. Whenever you build a new model of car, okay, everything is ready. You want to test it out. To test it out, you need to bring your car out of your manufacturing unit, and you need to travel on road. So by traveling on road, you can test it, how much speed it is going, what is the pickup time, all this stuff you want to test it out. So instead of going on road, what we can do, we can lift the car and we can just raise it, and we can see the wheel rotation and how much the pickup is happening. All this stuff we are doing at the same level. So here, instead of going on road, what we are doing, just we lifting, nothing but we are using some tool where we are giving like input that, okay, just feel that you are traveling on road and you increase the accelerator. Similar way, whenever we are doing the development life cycle, some X application is expecting some input from the Y application, but Y application is not yet ready. It is still in the development phase, but still I want to test my X application. Instead of waiting for until Y application is ready, we can give the inputs by marking some application. Just application X feels that Y application is already there and pick up these inputs from the Y application. So we manually give those Y application inputs by using some tools that helps that hallucination of application X feels that, okay, my previous component is ready and it is giving inputs for me, and from here I need to process it. That's how marking we need to do. Marking quite frequently used in the initial application development phases. Once application is developed and deployed into the production, by the time all the applications are ready, after that this will disappear. This marking of the concept is disappeared because all the applications are ready and Y application is ready, X application is ready. Now whenever I need inputs from Y application to X, I can easily take it.
Yes, that actually makes sense now.
I have like one doubt actually. For suppose usually we don't have any DevOps background. So suppose if you go for any interview, no, so they're asking about the real-time scenario. So like, hey, what kind of project you done? So can you explain about that? So at the end of session, so you'll get any real-time project so that you can do the practicing on that. So
Yes, in my
so that's my concern.
curriculum itself, I have mentioned that we are going to cover to real-time projects. Okay, so yes, whatever we are doing or I am doing, I'm going to explain how my project does work at the end of the training, and also I'm going to bring a few guest lecturers who are already working on DevOps. They will explain their projects, how they are doing and what they are doing. So you will get some idea. Addition to this one, we also getting some DevOps requirements as a Veloxy Technologies directly. Few clients they already approached. We have given solution, but none of those were success. So we haven't developed those, but we have given a solution for them. So we will try to modify a little bit and we'll give the what was their environment, what they were expecting, and what solution we have given. So all this I'm going to explain so that you can understand that how to identify which tool would be the best, and how can you suggest that among these DevOps tools which would be the best for his case. So these kind of things we are going to discuss. Bye for now and see you again on Monday.